Hello everyone, this is me Arijit with a new video, and in this video we are going to build this. So basically this is a speech and web control surveillance spider robot. Now I will tell you like what it basically does, but the thing is that this is an updated version of one of our previous projects. So in one of our previous videos we built this same spider with Android phone, and not Android phone, smartphone control. Okay, so basically we control this spider using our smartphone using Bluetooth. Now after that video, like many of you really like that video and asked for upgraded version, so here it goes. And basically in this video we are going to upgrade it in such a way so we will be able to control it using speech. So basically I'll give it a name. So I have given it a name Bumblebee. Obviously you can give any other name. So whenever I will call it with that name, it will start listening me, and after that I can give it any kind of command. So let's say I say it like go forward, or maybe turn on the light, turn on the camera, and things like that, and it will do that. This is the speech control part. Then there is the web control. So basically in web control, so in the last video we control it using a smartphone, so using an app. Okay, now here we are going to control this using a web page. So you will open a URL from any of your like laptop, desktop, or any other device, and then you will be able to, so in that web page you will have all the options, and from there you will be able to control it. And now as it's a web page, it will be very much easier for you to add any options, or maybe you can also customize that web page. Okay, because obviously like I have written the code, so you can definitely modify it, so no third party app is involved here. Okay, then there is the live surveillance. So here there is a camera, and we can do live video surveillance also from a web page. So again you will open another URL and you will be able to see like whatever it is seeing from this camera. So these are the features we have in this upgraded version. And so let me show you a very quick demo of like how the end product will basically look like. Bumblebee, stand. Bumblebee, wave your hands. Bumblebee, sit. Bumblebee, please go forward. Bumblebee, camera on. Bumblebee, turn left. Bumblebee, turn right. Bumblebee, please go forward. Bumblebee, go backward. Now in this video I will try to explain you everything in detail so that you can build it, and also if you need to modify something you will be able to do it. So let's get started. Okay guys, so before I will show you how to build this, there are a few things we need to talk about. The first thing is, if you are new to this channel and if you are watching this video for the first time, then you need to watch few more videos, because in this video I will only show you the upgrade part. So basically you have at first you have to see how to build the basic part. So basically from where you will get this 3D printed parts, how to connect the servo motors, how to use the Arduino, how to program it and check if it is working or not, and all the things I have discussed in the previous video. So you please watch that video first, then you will understand how the overall thing is working, and then you come to this video and then you see how the upgradation basically work. Okay. This is the first thing. Now the second thing is for all the features here. So if you see the camera, the live surveillance and the speech recognition, for all of these features I will have separate videos. So basically to understand all these things in detail you have to watch those videos also. So as the video will go along I will also tell you which videos you have to see to understand that part. But again, like to understand this and build this you also have to watch those videos too. Okay. Now let's talk about the hardware requirement. So in the last video we have just used the servo motors and we had the Arduino Nano, and also we have a Arduino Nano IO shield and basically some batteries and some other stuffs. Okay, also we had a Bluetooth module. So obviously in this video we don't need a Bluetooth module because we are not going to build a Bluetooth control spider. But the remaining things will be just the same. So the Arduino will be there, the Arduino IO shield will be there, the servos will be the same, LED, battery, everything will be just the same. Okay. Now you may ask how I am going to control, how I am going to implement the speech recognition using Arduino. Now obviously we are not going to do that. Now the thing is that there are two ways to do this. One thing is what we can do, we can use a Raspberry Pi. No, we can use any single board computer, but obviously Raspberry Pis are my favorite, so I'm going to use a Raspberry Pi. Now obviously you cannot use a Raspberry Pi 3 because obviously the size is not that big that you can use a Raspberry Pi 3 board. So obviously Raspberry Pi 0W is I think the recommended Raspberry Pi for this project. Now I have used Raspberry Pi 0W. Now the thing is that one thing we can do is we will just replace the Arduino with Raspberry Pi 0. We will connect all the servo motors to Raspberry Pi 0 and we will code the whole thing in Python. This is the first thing we can do. But the problem is, the first thing is attaching all the servo motors with the Raspberry Pi isn't going to be that easy because I doesn't have any servo shield for Raspberry Pi, and I don't know if there are some kind of servo shield for Raspberry Pi. So connecting 12 servo motors with that single Raspberry Pi is not going to be that simple. This is the first thing. Okay. Obviously you can solder stuffs and that, but obviously I doesn't prefer that for this project. Now the second thing is writing the whole code, because in the last video we already have used the Arduino code. So we already have that Arduino code with us, which basically works just fine. Now again, writing a new code in Python for the same thing, it will take a lot of time. That's why what I have did is I have taken a different approach. So our Arduino will be in the same place. We are going to connect our Arduino with Raspberry Pi. Okay, how we will connect I will show you. But our Raspberry Pi will work as a master and our Arduino will work as a slave. So our Raspberry Pi will give it commands and our Arduino will do that. So basically controlling the servos, all the codes will be inside our Arduino. So our Raspberry Pi will take the voice commands inside, say go forward, or Raspberry Pi will take it and then it will give a command to the Arduino that hey, you go forward. Then Arduino will basically control the servo so that it will go forward. So in this way all the servo motors, LEDs and everything will be controlled by the Arduino, and the Arduino will be controlled by the Raspberry Pi. This is the overall thing will work. So only thing we need for this upgradation is a Raspberry Pi 0W and a mic. Now again, we don't need any other power supply also, because in the last video we have used a 5-volt supply and that will be enough for our Raspberry Pi. But again, we will talk about that thing when we will talk about the hardware. I will show you how I have connected everything. Okay. And also another thing will be required is a logic level shifter so that we can connect the Arduino Raspberry Pi. Again, I will show you that. So this is about the hardware part. So there is nothing new. So if you already have built this project from my last video, then the hardware upgradation will hardly take few, I think, minutes maybe. And second thing is the speech recognition part. Now in Raspberry Pi 3, speech recognition and hot word detection. So if you don't know hot word detection, it is that I am calling, say let's say I call it by Jarvis. So I say Jarvis and it starts listening me. This is called hot word detection. And speech recognition, you know, so I say go forward, so it will know that yes, I have said go forward. This is called like speech recognition. Now the thing is that In Raspberry Pi 3B plus, it would be like very easier to implement these things. But Raspberry Pi 0, we have 5, like the RAM is very limited, you see, and that's why implementing this speech recognition thing locally is not that easy. Now, obviously, hot word detection can be implemented locally; it's not that hard. Okay, but implementing the speech recognition, it's not like, I'm not saying it's impossible, but it's a little bit like hard in Raspberry Pi 0, obviously because the RAM is limited and also the processor is not that powerful. So that's why here we are going to use a third-party speech recognition system. It's called Pico Voice, but again, it's free. You don't need to pay anything. It's obviously totally free. There are other alternatives too. You can use any of them. I am going to use Pico Voice because it comes with a hot word detection and also the intent detection. We will talk about that, what that intent detection things are. But it's free and it works pretty well. That's why I'm going to use Pico Voice for this video. There are other options for you too. Okay, so you can use those options too. Okay, now this is about the speech recognition. Now third thing is web control. Now for the web control, basically we are going to write the code in Flux. So Flux is a like Python framework, so we are going to write the code from scratch, so no third party involved. So you will be able to modify everything. If you want to modify something, you will be able to do that. So we are going to use Flux to write the code so that you can control this card, everything from any web page. Okay, you just open the URL and you are done. Finally, the camera thing. So obviously I have used Raspberry Pi 0 camera. Now for the camera part, I'm going to use something called RP. So I will show you when I'll use that. So basically it's RPI, I think RPI webcam interface, something like that. I'll show you when I'll use that. So basically using this technique, like the real-time surveillance, the video surveillance will be almost real-time, so it's a very good service. Okay, and again, it's open source, so no issue, you will get the code and everything. So this is how the overall thing will build. Now I will show you step by step how to go. We'll start with the hardware, then we'll talk about the speech recognition part, then the web control, and finally the camera part. Okay, and then at the end I will also talk about how you can do it differently. Or okay, so this is all we are going to explore in this video. So it can be a little bit big, so let's see. Okay guys, so let's talk about the hardware first. So this is the thing we made in the last video. So the only change we have to do here is, if you see that I have removed the Bluetooth module. So here we have that Bluetooth module here. Okay, so AC05, now I have removed that, except that everything is just the same. Okay, again the diagram will be in the description. So basically I have uploaded a diagram in the GitHub repository, and the link of the repository is in the description, so you can just see the diagram. And also please watch the video so that you will understand how everything is connected. Okay, now the thing is that so if you watch the previous video, in that case you know how everything is connected. Still I will just recap everything. So here we have two lithium ion batteries, so we are getting around 7 to 8 volts. After that, here we have LM2596, which is a buck converter, which is basically converting this 7 to 8 volts to 5 volts. Now we are taking that 5 volts and we are giving that to this Arduino Nano shield. Okay, and from that shield the Arduino Nano is getting power. Now with the Arduino Nano, we have with the shield we have connected 12 servo motors, and also we have connected to LEDs. Now how we have connected the 12 servo motors and how they are numbered, all these things I have discussed in the last video. And also the numbering, so the numbering diagram, like which servo is which number and also which pin to connect with which servo, all these things are in the GitHub repository. You go there and there are the images, you will get everything. So in one image you will get which number, so basically which servo corresponds to which servo number, and then which servo number to connect with which pin. Both of them you will get there. So you please watch that, and according to that you please connect them. Also watch the last video, there I discussed how to connect all these components. Okay, now with that part, one thing that I said, that we have to remove the AC05 module. This is the first thing. The second thing is I have added two jumper wires, female jumper wires with the power supply. So from the 5 volts I have taken one jumper wire, and from the ground I have taken one jumper wire. Now these two jumper wires I am going to use for my Raspberry Pi. Okay, now as we know, Arduino Nano also works in 5 volts and Raspberry Pi also works in 5 volts. Like, I mean 5 volts mean basically you can give power Raspberry Pi using 5 volts. So we are going to use these two pins to power our Raspberry Pi. The remaining things here will be just the same. Okay, now after you have like tested this whole thing, so with the Arduino Nano you have tested that yes, everything is working fine, then you can go and add the Raspberry Pi and check. Okay, Now let's talk about the Raspberry Pi now. This is how the Raspberry Pi connections will look like. So what I have did is I have connected the Raspberry Pi camera here. Now if you don't know how to connect a camera with Raspberry Pi Zero, in that case I have a separate video where I have to talked like how to connect a Raspberry Pi Zero camera with Raspberry Pi Zero camera, and also how to check if the camera is working or not. So you please watch that video, you connect the camera and you check if it is working or not. This is the first thing you need to do. Okay. The second thing is here I have connected the mic. So if you see, you cannot connect a mic directly with the Arduino, the Raspberry Pi Zero. You have to use a OTG. So here I have used this OTG. With that OTG, I have used this mic. Now I have bought this mic from Amazon. You can simply search this kind of small mics in Amazon. But one thing to remember, all mics doesn't work with Raspberry Pi Zero. So I just bought this mic and I checked and it worked pretty well. But again, while you are buying any mic, make sure that work with Raspberry Pi Zero, because like I said, all mics doesn't work well with Raspberry Pis. The second thing is you need a OTG. You connect that mic with the OTG, something like this you connect, and then you simply connect the OTG with the Raspberry Pi. Okay. Now one thing to remember is here there are two pins. So there is one, two USBs. One is written as PWR, one is written as USB. Don't connect this with the so PWR, just connect it with the USB. PWR is just for power, and so you have to connect this mic with the USB. Okay. Now here we have this logic level shifter. Now the thing is, why we need this thing? Why we can simply connect our Raspberry Pi with the Arduino? Okay. We can simply, you may say that yes, we can simply connect the RX of Raspberry Pi to TX of Arduino and TX of RX of Arduino to TX of Raspberry Pi, and then we can simply do serial communication. But it's not going to work. Why? Because our Arduino works in 5 volts and whereas our Raspberry Pi works in 3.3 volts. Okay. So you cannot simply connect them, because in that case there is a chance that your Raspberry Pi may get damaged. So that's why we need this logic level shifter. This will basically, so in a logic level shifter, there are two sides. One is a 5 volt side, one is a 3 volt side. You connect the 5 volt side with Arduino and 3.3 volt side with Raspberry Pi. So that whenever there will be a signal for 5 volt signal from Arduino, it will simply convert that to 3.3 volt signal and will send to Raspberry Pi, so that our Pi will not get damaged. Now how the connections of this logic level shifter will work and how we can check if this is working or not, I'm not going to discuss in this video, because I already have a separate video on this topic. So the link will be in the description. You please watch that video, that how this logic level shifter works with Raspberry Pi and Arduino, and you please check that it is working or not in your case, and then only you connect to it, you use this in this project. Okay. So same for the camera. So you please check the camera video and see if camera is working or not, then only use this. Same for this logic level shifter. At first you please check that your Raspberry Pi and Arduino can communicate with each other using this shifter, then only you use this in this project. Okay. Now coming to the mic, I doesn't have made any separate video on this mic thing, so how to set up the mic in Raspberry Pi Zero, but don't worry, maybe the next video I will make on this topic, and also I will give the link in the description. So maybe when you are watching this video, already that video is available, so you can go to the description and check how to use a mic with Raspberry Pi Zero. So there is no difference. If you know how to use it Raspberry Pi 3 a mic, it is just the same, but still I will cover this topic in a video. Okay. So this is how the connection from Raspberry Pi side will look like. Now, like I said, we have a 5 volt VCC and ground pin from our from this LM2596. You just connect that 5 volt pin with the 5 volt pin in Raspberry Pi and ground pin to the ground pin of Raspberry Pi. Okay. Again, all these things are in the diagram, so you can check that out also. But still, I'm saying that the 5 volt pin will go to the 5 volt pin in Raspberry Pi and ground will go to the ground of Raspberry Pi. Okay. And then you need to connect the so basically from the logic level shifter, one side will go to the Raspberry Pi, which I have connected here, and the side will go to the Arduino. You just need to connect that side with the Arduino. Now again, how to connect, you please watch that video, there I have discussed everything. So then you will take this part and you will put it here, you will connect all these pins, and then you are done with the hardware thing. So like I said, there is nothing special in the hardware part. So if you have already built this spider like from my previous video, then there is nothing. You only need to attach this few parts, and you have to attach this part with this part. This is the only thing you need to do. But again, make sure your camera is working, your mic is working, and this logic level shifter is working. That means your Arduino and Raspberry Pi can communicate with each other. Okay, so make sure all these things, then you connect with it. Okay, and another thing is, make sure all the servos are working with the Arduino. How to check? I have like already explained you this in the last video. Also, I have given you a sample program using which you can check that. So you please watch that video and please check if all the servos are working with this Arduino or not. Okay, so after you will check that yes, everything is working just fine, your spider is going forward, backward, left, right with this only Arduino, then you connect this Raspberry Pi with this, and then your hardware part will be done. So okay guys, so here I have fixed everything in such a way so that I can simply close this lid like this, and then I can simply attach the nuts here. Okay, and so if you see here, we have this like Arduino, and in the top side here we have this Raspberry Pi Zero, and also we have the camera and also the mic. So let me show you. So at first we have to open this like mic. Okay, and then if we see so let me show you. So this is the Raspberry Pi Zero here I have connected. Okay, and with the Raspberry Pi Zero here I have the OTG, and if you see here I have the logic level shifter. Now I have used some hot glue to put the logic level shifter here, and here I have the camera in the front side. Okay, so from the Raspberry Pi I have taken the camera and I have fixed it here with the help of hot glue. In here, as you can see, I don't know if you can see it. So here I have attached the camera with the help of some hot glue, and then here I have attached this like logic level shifter, and then I can simply put this Raspberry Pi over it in such a way, and then I can close this lid. Okay, so this is how I have managed everything. No, though the space is not enough here, to be honest. Okay, but still you will be managed to put everything. Okay guys, now coming to the coding part. At first I want to talk about the Arduino coding because that's the simplest step, I think. So here you will get the code in my GitHub repository, so you just need to upload that. So let's talk about that at first. So if you already have watched my previous video, then you know this GitHub repository. This is for my old project Spidey the spider robot. Here all the codes are for that Bluetooth control robot. Okay, now you already know that the legs are for this legs folder contains some code which will basically test if every servo is working or not, and also for the like initialization. And in this program one, it is for testing that if your bot is working properly, so if it is going forward, backward, left, right, if everything is proper or not. So I hope by this time, so before you are implementing the voice control bot, you already should have tested this two codes. So the legs you obviously have to do, and the program one also you should do. So you will check that yeah, everything is working, your bot is going forward, backward, left and right. Okay, now after you have uploaded these two programs, you know that your robot is working properly. Then you go to this repository. Okay, so here it is called Spider, a speech and web control surveillance spider robot. Okay, now this is a repository where you are going to get all the codes for this project, so this voice control and web control part. Now if you go to this repository, the first thing you will get is Spider Arduino. So this folder basically contains the Arduino code. So if you open it, you are going to get three files. This is FlexiTimer 2 CPP, FlexiTimer 2H, and Spider Arduino INO. Now this FlexiTimer 2 CPP and FlexiTimer 2H are same as previous ones. So in our previous code also we have these two files and they will be same here too. The only change we are doing is like we are adding this Spider Arduino. So this is the code you need to change. So you need to upload the Spider Arduino code. Okay. Now let me show you what this code actually contains. So you don't need to change anything. If you have like connected all the pins like I have did, in that case you don't need to change anything. It will just work just fine. But still I just want to explain you so that if you have changed anything, so that you can actually modify this code. Okay. Now FlexiTimer 2, you don't need to change anything. Only the spider remote you have to change, and only few parts you may have to change. So we will only talk about those parts. So the first thing is, if you have changed any pin number, then you come here and you change this servo pin number. So here I have from 2 to 13 I have, but if you want to change anything, you can change it. Okay, and this you may have to change. and there's nothing else. Also, if you also here you will get the LED. So if you want to change the LED pin number, so in that case I'll show you where to change it. Now coming to the servos, you just need to change this like the array. For example, if you have maybe you have used some other pin, then in that case you can change this accordingly. Okay. Now in setup you don't need to change anything actually. Another thing is whenever we are going to start this bot, it is going to stand. So I have called the stand function inside this setup, basically into this setup. So if you don't want, so whenever you will like basically turn the power on of this spider robot, it will stand. So if you don't want this feature, you please remove this line and then like it will not stand. Okay. But anyways, it doesn't hurt, so it's totally fine. Now here you don't need to change anything. Coming to the void loop, here you may have to change things if you want to. So if you have already watched my previous video where I have talked about the serial communication between Arduino and Raspberry Pi, in that case you know already that like how the serial communication actually works. But so for example, here if you see, if there is some serial data available, we are going to get the data inside our data, and then based on the content of the data we will decide if we have to go forward, backward, or whatever. So for example, whenever our Raspberry Pi will send f, small f, so basically when our Raspberry Pi will send small f, whenever in our Raspberry Pi we will say go forward, it is going to send the small f, and then what this Arduino will do, it will call the step forward function and it will pass 5. Now why 5? 5 means 5 steps. Now if you want 10 steps, you write 10 here. If you want 15 steps, you write 15 here. Whatever it is, you can write it. Okay. Also, if you want to make it variable, you can do that. In that case also you have to change few things in the speech recognition part, but yeah, that is also possible. Now here one thing is that whenever you are controlling through the voice, the step is fixed. So I have used in this way. So whenever I will say go forward, it will go 5 steps, 6 steps, 10 steps like this. But whenever we are going to use the web control, in that case it's not fixed. So till the point you will press the button, your bot will go forward or backward, whatever button you have pressed. Okay. Now if you see here, step forward, step back, step left, and turn left and turn right, these 4 functions we have called if you are passing f, so small f, small b, small l, and small r. Okay. So this is for the voice control part. Now coming to the web control part. In web control part, we are going to send capital F, capital like B, capital L, and capital R. Why? Because in web control part, we are not going to do this step thing. So till the point you are like pressing the button, your bot will like go forward. If you are like using the forward button, and same for all the other buttons. And that's why if you see here, I have called a sys step forward. So step forward basically is like just going forward for few steps. So in that case, we were passing 5 or 10 in bracket. But sys step forward is for continuous forward. So till the point you are pressing the button, it will like go forward. Okay. Same here, C step back, and like C turn left and C turn right. So C before the function name basically it means that continuous. Okay. And then we have this X here. So capital X for stand, small x for set. Then we have this W, capital W to turn the LED on, small w to turn the LED off. One thing here is that I haven't declared any pin for the LED, so I have directly written 14 here. So if you want to change the LED pin, you please change it here, or also you can declare at the beginning. I haven't did it, I somehow forgot it, so please do this. And there is capital B and small v for hand wave, and there is U for task, small u and capital U for body dance. Okay. Now if you want to add any feature here, what you can do, you please declare another this kind of character. So if for example you say if the Raspberry Pi send P, then I will do this. If the Raspberry Pi send Q, I will do this. In this way you can do it. You can add new features in it. Okay. Now after this you don't need to change anything here. So if you see here, this is turn left. In turn left, we have that we are passing that integer value, and based on that, it is going to do that many steps. Okay. And if you see C step, like C step or C turn, in that case, that function is continuous. So you don't need to change anything in the function. Okay. Still, I just showed you, like explained you how it basically working, so that if you have changed anything, you can change the Arduino code. Okay, so this is how you change the code if you need it, and then you simply go to tools, you select Arduino Nano obviously, and based on the processor, you have to select the processor. In my case it was Atmega T28P old bootloader, but in your case it may be different. You go to port, you select the port, and then simply you press upload here. Okay, and you are done. You don't need to do anything else. Okay guys, now let's talk about the speech recognition part. Now before you can do this, there are a few things you have to make sure. The first thing is that you have to make sure that your mic is working. Now, I have already shown you that in Raspberry Pi Zero, you have to connect a OTG at first. Okay, in the USB that, so basically there are two USBs, one is written PWR and one is USB. You have to connect the OTG cable in the USB, okay, where the USB is written. And then you can connect either a USB mic or you can connect a sound card, and then with the sound card, you can connect those mics which have like 3.5 mm jack, okay. Now this is the hardware part, and coming to software part, like the audio setup is same for Raspberry Pi 3 and Raspberry Pi 0. So if you know how to set up like audio or a mic in Raspberry Pi 3, you can also do the same for Raspberry Pi 0. Now I am not going to cover the mic setup in this video, but I will make a separate video. Maybe the next video I will make on the mic setup, and I will put the link in the description, so that if you don't know how to set up a mic in Raspberry Pi 0 or Raspberry Pi 3, you can watch that video. So after you have checked that yes, your mic is working just fine, now the thing is that we have to do speech recognition. Now for the speech recognition, there are two parts. One is hot word detection, and then there is a speech recognition. So hot word detection means, like, let's say we give it a name Bumblebee. Now whenever I will call Bumblebee, our spider will start listening us, and then I will give it a command that go forward. Okay, we are not going to do like I will say go for it will go forward. In that case, whatever I will say, it will try to understand that. So if even I'm not giving any command to it, it will still try to speech recognition. So that is not needed. Okay, so whenever we will call that, then only it will listen to us. Okay, that's why hot word detection is needed. Now how we can do hot word detection is, there are several options we can use. So for example, there is something called Snowboy hot word detector. That's just it is a very accurate open source hot word detector, but the thing is that we are not going to use this in this video. So I'm going to use a different service, but this is the option you can use. That's why I just show you this. Okay, now so we are going to use in this video something called Pico Voice. Now in Pico Voice is a service. So if you just search Pico Voice in Google, you are going to get this. Now they provide different voice data services. So they give like speech recognition, hot word detection, intent detection, and a lot of things. Okay, and the best part is like it's free. So if you're a hobbyist and making some projects, it's totally free for you. Obviously not free for enterprise purposes, but for hobbies it's totally free. Okay, and it's also very much accurate. Now you may say like, why we are not using any offline hot word detector or offline speech recognition system? The simple reason is that it's Raspberry Pi 0. If it was Raspberry Pi 3, in that case definitely there are several options. There is like we can use there is a Python speech recognition library, we can use that also, and there are many other options. But coming to Raspberry Pi 0, using a local speech recognition system is very hard due to the, obviously the RAM is limited, the processing power is also limited. So it will make the whole device slow. So we don't want that. We want like whenever I will call the robot, it will listen to me, and it should do like it shouldn't take a lot of time in that. That's why we are going to use Pico Voice, because it will be very much faster. Okay, so whenever we will call it, it will respond like almost takes, I think, a few seconds, I think 1 or 2 seconds to recognize the sentence. So it's very fast, and that's why we are going to use this in this video. And also the documentation is very clear, so even you can simply go to the documentation and read all about that. But still, I'll just show you how to use this anyway. Okay, so now it is clear that we are going to use something called Pico Voice for the speech recognition and the hot word detection. Okay. Now the thing you have to do is, this is the Pico Voice GitHub repository. So you have to clone this. Now while cloning this, make sure one thing: in this GitHub repository, in the resources folder, there are two more resources for so it's called Porcupine and Rhino. Okay. Now these two are basically submodules. So you make sure that whenever you are actually cloning this whole repository, you should also clone these two submodules. Okay, so you can use git module, so git clone, or also what you can do, you can simply download this whole repository and put in Raspberry Pi. But whatever you are doing, make sure that these two folders should be there. So Porcuno and Rhino. Or if you are doing using git clone, and if you see these two folders are not there, in that case what you do, you just open this two repositories separately. You go to that folder in the Pico Voice, and then you clone these two folders, because without these two folders it will not work. Why? Because Porcupine is the hot word detection part. So Porcupine basically do the hot word detection, and Rhino basically do the intent detection. Now what is intent detection? I will come later, but thing is that these two are very much necessary. So you please clone this part. So whenever you are cloning this, you're almost like, I think 90% of the work is done. Okay. Now let me now the thing is that which keyword to select. So for example, I am using bumblebee. So if it is like that, you can use any keyword, or like there are some, like, what I can say, limitations. So let me show you. If you go to Porcupine, so if you go to resources, Porcupine, and inside Porcupine, if you go to resources and then you go to keyword files, and then you have to go to Raspberry Pi, because you are using Raspberry Pi, we are using Raspberry Pi, then you will see these are the available options you have. So yes, you cannot use your favorite keyword here. Yes, it's not that you cannot use, you can use. In that case, you have to, I think, use the enterprise version maybe. Okay. And so there are many options actually here. There is Terminator, Porcupine, Pico, OK Google, Jarvis, Hey Siri, Bumblebee, Computer, Blueberry, Alexa. So there are a lot of keywords and you can choose any of them. They are already pre-trained. So coming to hardware detection, you have to, in most of the cases, so for example, in SnowPy or Snowboy also, I have used SnowPy previously, you have to train the keyword. So for example, if you are using maybe, let's say, sparklers, you have to say sparklers 10 times and you have to train the model, then you have to download download the file. Okay. In case of Snowboy, it's .pmdl file, you have to download that file, put that in the folder, and a lot of things you have to do. But in case of Porcupine, there is no training needed. You can use any of this keywords. Okay, so whenever I will show you a command, so whenever you are using the command, you have to mention the name. So for example, if you want to use Jarvis, in the command you write Jarvis Raspberry Pi .ppm. Okay, so in that case, in this way, you have to select a keyword. Okay, now this is the hardware detection, and hardware detection is done in this way. Okay, so and another thing is, you don't need to install any, I think, third-party library. Okay, so and if you get any error like this library is needed, you do just pip install and that library name and it will work. So there is no specific, like, no, I don't think there will be any issue here, because I didn't install any separate library for this using this library. Okay, this is the speech hardware detection part. Now coming to speech recognition intent detection. So what's intent detection is, like I say go forward. So let's say I want to say go forward. Now there are several ways you can say go forward, please go forward, can you go forward, it will be great if you go forward, and a lot of things will be there. Okay, so the basic thing is, we can say our same thing in different ways, right? So if you do normal speech recognition, in that case, what you can do, you have to say a specific word, forward. You always have to say forward. If you say please go forward, it's not going to work maybe. Okay, or maybe so for example, hand wave. So you can say please hand wave, or also you can say please say hello. Okay, so you want these two phrases to work. In that case, if you do speech recognition, you have to write all of these phrases in the if else, and it will be a mess. But intent detection is, like, we will say, okay, if the person says this, that means you want to say forward. If you say go forward, that means forward. If you say please go forward, that also means forward. If you say can you go forward, that also means forward. In this way, we will give it we'll give it like a list of sentences, and we'll say this sentence means this sentence means this, in this way. It's basically intent. So we are basically finding the intent from the sentence. But don't worry, you don't need to do anything. Rhino will do everything for you. So you go to this voice, picovoice.ai, and I will give the link in the description. From there you log in, you create an account, it's free, don't worry, and then you go to console. From there you go to picovoice console. Okay, and okay, you need to agree. And then there is a Porcupine wake word engine and Rhino speech to intent engine. You don't need to go to Porcupine wake word engine, because we are already using a already train file, so no need to train. And also train is not going to work for Raspberry Pi. It's not free. For Windows, I think it's free. For Raspberry Pi, it's not free. So we don't need to go here. You just go to Rhino, and there you have to create a new. So basically here you give it a name and create context. So I already have created a context called name go. So you create a context, you give it a name and create context, and then you are going to get the context here. So in my case, I have go. So if you open go, what you will see here, that here this is the format. So in intents, you will have all the intents, and whenever you will click any of the intent, you will see the expressions. So initially it will be empty. You have to add all of them. So you will go below and you see new intent. Here you write an intent. So for example, I say I can write maybe I don't know, fly maybe. Okay, obviously a spider cannot fly, but let's say fly. So fly is a new intent. So I go to fly, and then you give it expression. Our expression can be please fly, You can write, can you please fly? Also also you can write maybe go to sky. All these things we can write. So you can add as many expressions as you want, and after that, whenever you are going to, you will say any of the expression, our Rhino basically, or what you can say, our Pico voice will return as fly. So if you say go to sky, it will return fly. If you say can you please fly, it will return fly. If you say please fly, it will return fly. So it will be easier for you whenever you are writing the code. Okay, whatever you say, it is going to say, okay, you are saying this, that means you want to say fly. So yeah, it will be easier. Also, there are slots. Slot means it's like, please go forward 5 steps. Here, go forward can be the intent and 5 can be the slot. So I'm not going to do this now, but you can do this if you want. I don't want to make it complex, but if you want, you can do it. So after you will add, so here I have added all these things. So go forward, backward, left, right, light on, light off, stand, sit, dance. For all these things, I have added all these things. And after you are done, you have to click here, save. Okay. Now coming to fly, I really don't want it. Okay. And then you click on save, and it will take some time to save it. And after it will save, you are going to get a train option here. So you see train, so you click on train, and here you have to select the platform. So obviously it's Raspberry Pi for us. I understood. Yeah, I understand. Now you please click in the train, go for Raspberry Pi. It will take some time to train, and after it will train, you will get a model. You need to download that and put in your Raspberry Pi. Okay. Now the thing is that so you see training complete. Now you go to models, and there you are going to get a model. So you see I have created this model just now, and this model, and you can simply download it and put it in the Raspberry Pi. How you can put it? You can simply download it in your Windows, and then you can use FileZilla or any SSH, like any file transfer service, to transfer that file to Raspberry Pi. If you don't know how to do that, there is a separate video in my channel. Please watch that. Okay. Now you download this file, you put that in the Raspberry Pi, and one thing to mention here, this file is only valid for 1 month. Yeah, this is something, a limitation. So if you are creating a file, it is going to work for 1 month, and then you have to again train it again. Okay, so you simply come here. So these things is not going to delete. It's not like that your forward, all these things will delete. So only your module will expire. So you again come here, you again train, you again put the file, and it's totally fine. Okay, so this is the limitation you can see in case of Rhino. Obviously, if you're not using the enterprise version, and in case of Porcupine, you cannot like create a separate your own keyword. These two are the I think limitation, but still it works just fine because the performance is really great. That's why I'm using Pico voice. There are other options obviously, but all those options, even if you're using Google API, Google like speech to recognition API, you also need to pay. Obviously there is a free limit. I think there are certain keywords for free, but still you have to pay some amount, and in that case coding will also be like, it will be a little bit complex because there you are getting the raw text to speech. Then it will be not that easy, and also you have to integrate the hotword engine there. So you have this hotword engine, then Google speech API. It will be a little bit complicated, whereas in Pico voice is very much simple. Okay, so what you need to do, again I am saying that at first you just need to go to Pi console. From there you go to Rhino, you just create a intents, and then you train a model. This is only thing you need to do in Rhino, and then you train the model. You took the file and put the file in Raspberry Pi. Okay, now what you do, in the meantime you already have this Pico voice folder in your Raspberry Pi, right? So what you do, you put the file anywhere. Maybe you put the file in this folder somewhere here, you put the file. Okay, at the end I will show you my folder structure and all these things, but for now I'll just explaining you. So you put the file somewhere in this folder. Then in my GitHub repository there is a command mentioned. You see this command, so Python 3 demo. So I am so basically if you see in this folder, so you should be inside this folder while running that command, inside Pico voice, not inside Porcupine. Oh sorry, inside Pico voice. Wait a minute. Inside Pico voice you have to be there, and then you run that command. So that command is going to run this file inside demo. There is Python, and inside that there is a Pico voice demo mic.py. So this file you have to run, but again here also there is one thing you need to do. This demo mic.py may not run in Raspberry Pi Zero. There are some issues, and that's why this may not run. That's why I have modified this picoboys demo.file. Also you have to modify that. I will show you how to modify it, but the fact is that you only need to change this file in the whole folder, picoboys folder, and then you add the train Rhino model here, and then you have to call this command. So you have to run this demo python picoboys demo mic.file, which I will show you how to change. Then in keyword part, you have to give the keyword name. So resources for QPy, resources, keyword files, Raspberry Pi, and here you only need to change. In my case, I'm using Bumblebee. If you're using Jarvis, you write Jarvis. If you are using Terminator, you write Terminator. So you can see you can just go to the folder and you see available keywords and you write the keyword name here. Finally, in context part, you have to write your Rhino model name. So if your Rhino model is in the same folder, so if your Rhino model is here, you can simply put Rhino model name. So you see, you write context part and you just write your Rhino model name and it's done. Okay, nothing else. Again, I will show you in my Raspberry Pi how it basically looks. So, and now the final thing is coming to that file. So in demo, inside demo, like I said, inside demo, we have Python. Okay, where is Python? Yeah, inside we have Python. Inside that we have this demo mic, picoboys demo mic.py. Now in here you will get this code. So in my GitHub repository you are going to get this picoboys demo mic.py. So you open this file. I have modified this file already, so I will tell you where to modify it. So if you see here, I have only modified a particular thing here. So let me show you which thing I have modified. So the first thing is you have to modify this part. Now this part is for like this is the main part where so basically here we are. So if you see here the intent, so interference.intent is going to what? So after we are going to say that hot word, let's say called Bumblebee, and then I'll say go forward. In that case, this inference.intent will get forward. Okay, so it will consist of the forward. Then we are going to compare this inference.intent with our intents. So forward, backward, left, right, light on, light off, stand, set, all these things we are going to basically check if it is equal to this or not. So if it is equal to forward, we are going to write F in Arduino Serial. Now again, if you don't know how to communicate between Arduino and Raspberry Pi using serial communication, you please watch my previous video. Link will be in the description. Okay. So I have a separate video where I have shown you how to communicate between serially communicate between Raspberry Pi and Arduino. Okay. So if it is forward, you write F. If it is backward, you write B, L, R, W, capital W, small capital X, small x, U, V, depending on whatever we are saying. So if I say hand wave, in that case, you see here it is. So if I say hand wave, you see our intent name was wave. In that case, it will simply send capital V. Okay. Now camera, whenever I say camera on, so I say please turn on the camera, it will get camera on and it will turn on the camera. Now how to turn on the camera, I will show you. Okay. And so this part you have to change here. Okay. And if you are adding a new option in that also, you have to add in this part. Another thing you need to change here, which is if you see here in this run function, there is this infinite loop while true. Here in the original file, it is written as PCM equal to recorder.read, and I have just modified this line and I have added these two lines. So at first you try with this line, so you don't modify this and you check. You may get an error. I have heard many people with Raspberry Pi Zero got this error. I also got this error. So then you please comment the line, this line, comment this line, and then you add these two lines. Okay, and you check. The file is already in my GitHub repository, so you can simply copy or paste. Okay. And then you add these two lines and you check, and you should not get any error. Okay, so at first if you get an error, you add these two lines and check, and it should be just fine. So this is the only change you need to do. And like I said, after you have modified these things, you simply go to the picoboys folder. Inside picoboys folder, and you run this line. What you need to change, you just need to change this thing. So if you are not using Bumblebee name, I really like this Bumblebee name, but if you're not using Bumblebee name, you change it. And also here you must have to change it. So in context file, here you have to write the name of your model which you have just trained. Okay, this is what you really need to do, and the remaining things are fine. Okay, another thing, before you just run this thing, you also have to set up the camera part. So I will show you now that how to set up the camera part and things. Okay. Okay guys, now coming to how to set up the camera. If you don't know how to connect a camera in Raspberry Pi Zero, again I have a separate video on how to connect a Raspberry Pi Zero with a camera. The link will be in description. You please watch that video. In that video I have also shown you like how you can actually test if the camera is working or not. So at first you check if your camera is working, then you have to use this thing which is called RPI cam wave interface. Now again, how to use this thing, I have another separate video where I have shown you. So all the links of all these things will be in the video description, so you please see RPI, you please watch the RPI cam wave interface. So basically this is about how you can do live surveillance from the Raspberry Pi camera. Now why we are using this rather than there are other options also, because this is very like it works very real time. Okay, so the latency is very low here, whereas in others, so for example if you're using motion or many other tools, the latency will be very high. So the latency is very low and it works pretty well with Raspberry Pi Zero also. That's why I really love this RPI cam wave interface. So I have a video where I have shown how to use this. You please watch that video. So it's just you have to install this and you have to run this. Nothing special about it. So you please watch that. And then if you see in the code, so in the Pico Voice demo my code which I have modified. So if you see in the camera on part, I have written like this. So in the camera on os.system, that means I am calling a system command. I am writing that home pi RPI webcam interface start.sh. So you need to run, so basically you need to call this, you have to basically call this code. Okay, so this start.sh. Okay, this is the file you have to run. Now if you simply run like, if you simply write like home, so this is my location of this folder. So this in my case it is in the home pi folder, the RPI webcam interface. So you also please put the folder in the same folder. Okay, except that you have to change this directory. So let's say you have put it in desktop. In that case you have to write home pi desktop and then RPI webcam interface, then start.sh. So it is like this. Whenever you will call the start.sh, it will turn on the camera. Whenever you are calling the stop.sh, it is turning off the camera. Okay, so this is how. So whenever you will say like, hey, camera on, it will turn the camera on. When you say to camera off, it will call the stop.sh and it will stop the camera. Okay, so you please watch that video and then it will very much, so you will understand why we are calling the start and stop thing. Okay, in this way you can actually control the camera part, and after you will call it, you can simply open a particular URL. So I think it's 808, I think it's 80, port number 80. So you have to use a Raspberry Pi IP address with port number 80 and you will be able to use the camera. Okay, again the video is already there, so you please watch that and it will be easier for you. And now the only remaining thing is we have to talk about is the web control part. Okay, now let me show you the web control part also. So if you go to this folder, so there is a web control folder you go to. So now the requirements are here. You need Python 3.7.3 and Flux 1.0.2. So please install the Flux here. It's simple, like you can simply, so I think you can simply install Flux, I think using pip install. Okay, so you please watch how to install, like if you search installing Flux in Raspberry Pi, you will get it. You please install that and then you open the web control. It's really simple, nothing special. You just need to use a command. So you just need to run this web control.py file. So you will just write Python 3 web control.py and you are done. And then you open your Raspberry Pi IP address with port number 8081 and you will be able to see the web control thing. Okay, anyways, I'll show you, but this is how it will work also. Okay, and there is this template thing. So inside this template you have the HTML file. So if you want to change the theme, you can change it. If you want to add buttons, you can add it, whatever you want to do. And in the styles folder you have this main CSS, which is style file. If you want to change the style, you can change this file. Okay, so it is as simple as that. So you just copy this repository, just open this folder, you run this web control pi and then you open the IP with 8081 port, sorry 80 yes, I think I'll show you, like I'll show you which port number it is. Actually I also forgot, but again like you can run it in any port number. If you want to change the port number, you can do that actually, and then you run it in that port number. So if you see, I already have mentioned the command here. So you have to write Python 3 web control.py, and also it will show you actually whenever you will run this command, actually it will show you that which URL you have to open. So you open that URL and you will be able to control the part. Okay, now you may ask me, okay, it is fine, but how to run these two commands parallelly? Because you have to run this thing also and also run this thing also. So this is for the speech and this is for the web. How to run simultaneously? There are two things. what you can do, you can actually run this command in background. So run a command in background. You have to just add an ampersand sign at the end. You can do that. Also, what you can do, you can open two PuTTY terminals or whatever you're using. You can not add to open two terminals and you can run them simultaneously. And another thing is, what if you want to just like start this thing whenever your Pi will start. There is a separate video in my channel where I have shown you like how to run a code in the Raspberry Pi startup. You watch that video, and in that video you will be able to see like how you can start this, like how automatically start it whenever your board will start. Okay, now I will show you which videos, like I have talked about watch this video, that video. I will show you which videos you have to watch to understand the whole thing. And then also I will just open my Raspberry Pi and I'll show you how I have structured all these things and how basically I am running all these things and how you can do that. Okay guys, so now I'll show you in Raspberry Pi how I have set up everything. Now before that, let me tell you which videos like you have to see before you just do all these things. So I have mentioned that you have to watch that video and this video. So let me show you in my channel. So if you see here, this is the video Raspberry Pi and Arduino serial communication. This video you have to watch. The link will be all the links will be in description. Okay, so you can find it from there. So in this video I have shown you like how you can do a serial communication, like the basic testing that if the serial communication is working or not, and how to write a Python code and how to write the Arduino code to do so. So this video you have to watch. After watching this video, make sure that your serial connection in Arduino or Raspberry Pi is working just fine. Also, the codes of these videos are also in the description of that video. So you run that code and see that if it's working or not. Okay. The second thing is real-time video streaming from Raspberry Pi. So this video also you have to watch. So if you want to do that live video surveillance part of the spider, in that case you please watch this video. So in this video I have shown you like how to install the Raspberry Pi CAM web interface and how to test it, like all the testing, and I have shown you in this video. So you watch this one, and these two videos you have to watch. Except that you have to watch, this is the most important video, like the first video of this series. So how to build a basic spider robot with Arduino, this you must have to watch this video. And all the codes of the leg code and the testing code of the spider you will get in the description of this video. Okay, except that this video also you may watch like where I have shown you how to connect the Raspberry Pi Zero camera with Raspberry Pi Zero. This may you like if you don't know how to connect the Raspberry Pi Zero camera, you please watch this. Okay, and you can also watch these videos, like here I have shown you how to charge the lithium ion battery. Also this part, if you don't know how to use a battery with Raspberry Pi Zero, how to connect power Raspberry Pi Zero, in that case you can watch these videos too. Okay, so I will put all the video links in the description so that you can just go to the like links and please watch this video, so you will understand how the overall thing is working. Okay, now let's see. Okay, now let me get into the Pi. Now here I am going to use PuTTY for this. So now as you can see here, I am inside my Pi. Now in Pi, the first thing whenever after you are inside the Pi, you have to do is you make sure there is Python 3 is installed. Python 3 is there, and also install Flux. Now after installing Flux, you please you can just download this directory. Okay, another thing here is another video. If you don't know how to transfer files between Raspberry Pi and the computer, there is this video transferring files between PC and Raspberry Pi. You can watch that, and in this way you can actually copy this web control folder. Also you can git clone, simply up to you. So you please copy the web control folder, and so here the name is I think different. I think I have written some different name. So as you can see, I have a web card folder. Inside that I have this file. So here I have written as car1.py. So I was testing. So I can simply run Python 3 car1.py. So in your case it's webcontrol.py. Okay, I haven't renamed all these files here. So you just simply run it. You don't need to do anything. And as you can see, it is saying that serving Flux, and it is also giving you the link. The link is in your, so the port number is 5010, and the IP will be the IP of your Raspberry Pi. So in my case, I know it's 192.168.20. I think it's 2.221. You write the IP and then you write the port number. In my case, it's 5010. And as you can see here, you can see the web control. So let me tell you which basically button does what. So this forward is obviously, you know, like forward, backward, left and right. This is for power off. If you press here, it is going to turn off the Pi. Okay, and his turn light on, light off, camera on, camera off, sit, stand, hand wave, and dance. So all these options are here. You can add other options also. So in that case, what you need to do, you have to modify the Python code also, and also you need to modify the HTML code. So you modify the HTML code, and then you add the buttons, and then okay, let me show you the Python code so you will understand what to change in the Python code also. So if you see the Python code, here we have written all these functions. So if you are adding a new feature, you have to add that in the HTML file also there, and also you have to add the corresponding function here. Okay, so I'm not talking too much details about this, but if you know this plus stuffs, you will understand how it is basically working here. Okay, so this is how basically you can open this you can run this web card part, using which you can control. Even if you see, if we just if I just press any of the button, any of the keys, you are going to get the request here. Okay, so this is how it is working. So it's as very simple. You just go to that folder and you just run that file, web control file, and you are done. Now coming to Pico Voice, if you see cd Pico Voice, and inside this folder I have all these things. Now like I said, I have the resources. If you see, if I just go to the resources folder, you will see I have both the folder. Okay, as you can see, I have Porcupine and Rhino. I don't know if you can see, they are very small, but I can see both of these folders here. Okay, both of the folders I can see here, Porcupine and Rhino. Okay, so you make sure that you also should have both of the folders. Okay, now another thing is that also, as you can see here, I have already basically all of my train files. So as you can see, these are the train Rhino files .rhm, and so let me show you how to run this part actually. So for this part, the commands are already written in the GitHub repository, so you can simply copy from here. So the only thing I need to change in this query is, okay, sorry, as you can see here, so here I have the command python 3 and the name of the file is picovoice demomic.py. Then in the keyword part I have this. Okay, here I have the Jarvis one, so let me change it and let me show you. So here, as you can see, if you see here, it is written as Raspberry Pi Jarvis Raspberry Pi.ppn. So let me change it and put it Bumblebee here. So as you can see, now I have written Bumblebee, and I just have written bum, and then I have pressed the tab button, so it would like the full name of the file. And finally in the context path, I have this written the name of my train file. Okay, so you have to copy your train file and put the name here also. Okay, and then I can simply just press enter and it will simply work. Make sure your mic is connected, else it will not work. And after you will run this is how it will look like it will say listening. And now if I say Bumblebee, so as you can see, the wake word, okay, it says the wake word and didn't understand the command. Okay, and this is because I have just said Bumblebee and I haven't said any command. Now if you say, I say go forward, nothing will work because I haven't said the sorry I haven't said the wake word. Now you see Bumblebee, go forward. So you see it says wake word, intent forward. Okay, so that means that it has detected the wake word and also it has detected the wake word intent forward. Now whenever it will detect the intent, it will automatically do all the stuff. So it will send the AF, our Arduino will receive the AF, and then Arduino will basically turn the servos on accordingly and our board will go forward. So this is how the overall thing is working. Same for the web control also. In the web control also, whenever you are pressing this button, okay, quite it is. So when you will press this button, automatically the Python function will get triggered and it will basically send the signal to our Arduino. Arduino will take the board to forward. So this is how the overall thing is basically working here. And nothing else to show you actually here. Oh, another thing I have to show you is also in the same folder. If you see, I have that RPA webcam folder. So if you see RPA webcam interface, I also, so make sure this all should be in the same folder. Okay, not same folder, but it should be in the home directory. Else you have to change the directory in the code. So if you see, I go to this folder. Inside this folder there are two files. There is the start.sh and stop.sh. So if we just run start.sh, it will turn on the camera. Stop.sh, it will stop the camera. Okay, as simple as that. Okay, let me show you a demo actually here. So let me just run start.sh. And I think it will, yeah, and it has started. So now what we do, we will again write the, so this IP is written here. Let me write 80 here, port number 80 it will run. And as you can see, let me, yeah, so now if I just open HTML, as you can see, you can, I hope you can see my hand here. Also you can make it full screen. In this way it is working. Okay, now how to install this, you please watch the previous video. There I have also I have explain how everything basically works. Okay, now let me just stop it. So if you just write that stop.sh, it will stop it. Now you see it's not running actually. So now even if I use hover my hand, it is not going to show you. So it has been freezed. Okay, and now so basically in the code we actually are calling the start and stop. So if you see the code, let me show you again, not this one actually. Yes, this code, if you see, as you can see, whenever we are writing that camera on camera off thing, what it is doing, basically it is starting the camera, and it is basically it is running the start.sh, and it is basically that stop.sh. Okay, this is all it is doing. And as you can see, it's in the home folder, home Pi RPI webcam interface. So if you have these files in some other folder, accordingly change this directory only, nothing else you have to do it. Okay, and also if you see in this here we also have all this diagram. So if you see spider control interface, okay, or this is the image of the control interface, nothing special. If you see spider png, okay, not anything important. Yeah, servo numbers.png. So here if you see, this is the numbering of the servo. So which servo you have to, so now you may say what is S1, what is S2, S3. So it is basically this numbering of the servo. So we are considering this servo as 1, is this servo as 2, this servo as 3, 4, sorry, not 4, 4, 5, 6, in this way, 4, 5, 6. In this way we are basically considering. Now why we need to consider in this way? Because I will say, so in the, when you will see the diagram of the connection, or you will see the code, it will be like servo 1 is connected with pin number 2, servo 2 is connected with pin number 3. So to connect this, you also have to know the servo number. So you will know, okay, this servo I have to connect with pin number 2, this servo I have connected with pin number 3, in this way. So these are some servo numbers, not pin numbers. Don't don't get confused. These are servo numbers. S1 servo 1, S2 servo 2. Now let me show you another diagram, which is basically circuit diagram.png. So this is the whole circuit diagram. Okay, it is too big, and okay, I cannot resize it here, so I have to download it. Yeah, so if you see here, so I have 6 servos, but I haven't connected all of them. Okay, because here I have written all the servo numbering. So as you can see, servo 1 to digital pin 2, servo 2 to digital pin 3, servo 3 to digital pin 4, servo 4 to digital pin 5. In this way I have written all the numbers you need to know. Okay, this is how you will connect the servos. Here we have the LM2596 to convert the 12 volt to 5 volt. Then from there, here we have the basically that logic level shifter connections with the Raspberry Pi and Arduino. Again, everything is mentioned. And here we have the LED. One thing important, don't forget to connect the resistor with the LED, else your LED or the Pi or the not Pi, Arduino can get damaged. So make sure you are using a resistor with it. So you have the circuit diagram, you also have the servo numbering pins, you also have all the codes. So I hope there will be no issue here, but still if you get any issue, you can also comment down. Okay, now after you have set up everything, the first thing I think is, obviously again so as a final check, the first thing is you have to check if every servo is working. Through the previous video, there I have shown you how to check if everything is working or not. Second thing, make sure your camera is working and your RPI cam web interface is working. The third thing is make sure that your serial communication is working. Just do some testing. I have shown you in that previous video how to test. And then make sure your mic is working properly. I haven't made any video yet, but I'll make it. So check that. Then you run all these things. You check if your voice recognition system is working properly or not. Then you check if your that flux thing is working properly or not. And then if you have checked everything, then finally you just, what I can say, you fix the Raspberry Pi inside the bot, and you just finish your project. Okay, and after that, if you have an issue, you can also always comment down or mail me. Okay, So this is all about this video, guys. So I hope you have liked this video. So again, all the codes, diagrams, everything is in the description. So in the GitHub repository, and the link of the repository is in the description. And also, if you have any queries, like, you can also comment down, or our Facebook link is also in the description. So you can also reach out me there. And also, if you have any other suggestions, you can also comment that out. Okay. And if you have liked this, then please like the video and subscribe to the channel, because in future I'm going to make many other videos like this and many other projects also. I am already working on many projects, so those videos will come very soon, guys. So stay tuned, and I will see you in the next video.